Well, this is John Black, Super Chemist. Last part 3, how to make, trying to make TERT pentyl alcohol. Keep in mind, this is not an instructional video. This is a blog or vlog or whatever you call it of me learning this reaction. This is only the second time I've done this reaction. Keep in mind, ether is flammable, very flammable. And I'm sure that the tert butyl and all these chemicals are all bad for your health. So if you repeat anything in the video, do it at your own risk. Throw that in. Yeah, maybe one more. Yeah, there you go. That's good. I'm going to throw a stir bar in there. Now, why am I putting in magnesium? This is magnesium sulfate. I don't know if I messed up and called it calcium chloride, but this is magnesium sulfate. Why am I doing that? Instead of calcium chloride, because calcium chloride forms complexes with alcohols, right? And they precip out. And but usually, I think it's just for lower alcohols like ethanol and methanol, maybe even isopropanol. But that's like if you're making ether from ethanol, it's good to use calcium chloride. That way, not only do you soak up the water, but you soak up the ethanol that, came over during the reaction, you know what I'm saying? But here, we're making alcohol. We're trying to make tert pentyl, right? So we don't want to use calcium chloride. Even though it's a bigger, it has a lot of carbons, it probably doesn't form a complex. But maybe it does just a little bit. And even if it does a little bit, we don't want that. So use magnesium sulfate for this. I'll let that stir a little bit, you know what I mean? Maybe let it sit for an hour or whatever. You can see it's still yellow, still clear. I'm going to start just a little bit before I put it into this fit funnel here. The reason why is because the liquid is thick and it sticks to the stuff, the salt. And if I put it in here, I can put the vacuum pump on it, and it'll suck the salt dry instead of leaving a lot of my product caked in there, right? And I'm just going to pour it right in here. And there you go. Now I can distill it. So I set it up for fractional distillation. Let's see, got the thermometer up there. But I already did it. And that's what is left inside in the pot. Just a bunch of black crap. This is what I got. This is a 25 milliliter flask. So that's about half, say almost half. So say 12 milliliters. And that is pure. I distilled that between 101 and 103 degrees Celsius. Now this I distilled before that. Another 25 milliliter flask. That's probably about 20 milliliters, say. So this is probably, I didn't get all the water out. I bet this is 70% tert pentyl alcohol and 30% water, whereas this is 100% tert pentyl alcohol. So I'm going to put this back in the Dean Stark apparatus, this azeotrope one, and just see if I can get some more water out of it. Alright, so I got the bigger quantity here, the one that's the azeotrope, right? That is filled up way too much. You should never fill up a flask more than halfway, but I'm just like, screw it. We'll see how it goes. You can see it's the same dealio. I'm going to distill it up. I got my water cool condenser. Everything will come down into here and fill up and separate into two phases. Now there's about 21 milliliters in there. If, say 30% of it is water, then there should be 7 grams of water in there, or 7 milliliters. So we'll see first if this bites me in the ass for filling it up so high, and also how much water is still in there. Now, I lost the footage on this, but I put it in the Dean Stark and I filled up, you know, you got this part over here, the test tube part. Now, there's the test tube part. I distilled it up. I filled up the test tube all the way up. Now I let it run for like an hour or two. And the only thing it collected was like a little bead, like a little, like if you had an eyedropper and a drop, you know what I mean? And I couldn't get nothing else to come over. And after a couple hours of it being already filled up and still nothing but that drop, I assume there's no water in this. So if I have time, I don't know if I will. I don't think I will. Especially since I combined these together like an idiot and I forgot. But what I wanted to do was distill it a second time, that lower fraction. You know what I mean? That had the impurities in it. And I ended up mixing them together like an idiot. So I'm not gonna, but I should have distilled that one again, and then taken my upper boiling points of that and put it with the, you know, the 12 milliliters that I got that was definitely pure. And then I would have had ultra pure. That would lower my yield. But oh well, that's all I got time for. Okay, I took everything from 90 degrees up to a 100 and I think it went up to 102 or 103. The boiling point is boiling range is 101 to 103 Celsius. So may not be pure. Maybe I'd have to distill it a second time. But that's good enough for me right now. I got about 35, 36 milliliters, probably 36 milliliters. So we'll see what the yield is on that. Okay, now what's our yield? We got the molar mass and the density on Wikipedia, and we figured out the molar volume. So the 1 mole was 109.5 milliliters. Remember, we divided everything by 2, though, remember? So we're going to divide this by 2 also. That's 54.75 milliliters. That's the theoretical yield. That means if you got 100% yield on everything, you would get that much. We got 36 milliliters. So I divide those two, right? And I get 0.66, which is 66%. So my overall yield was 66%. But there were 2 reactions. Remember, there was the reaction so that we can make the grignard reagent, and then we did a second reaction called the grignard reaction to make our TERT pentyl alcohol, right? So it was actually 2 reactions. The way you figure out your average between those 2, I mean, one might have been higher, one might have been lower, but on average between both of them, you take the square root of your percentage in decimal form, which was 0.66. Take the square root of that, you get 0.81. So that means each reaction got 81%. And I did the math over here this time, so in case someone doesn't understand what I'm saying. Our theoretical yield was 54.745 milliliters. If we got 81% yield on the grignard reagent, that gives us 44.5 milliliters. Then we did the second reaction. If we got another 81%, that would be 36 milliliters, and that's what we got. So overall, it was a 66% yield, but per each reaction, it was 81%. I did learn a lot, though. This is only my second grignard. You can see my last grignard, I think I got like a 21% on average of both reactions, which was like a 5% or something like that overall. This time I got, you know, a lot better yield than last time. So hopefully the next time I'll improve even more. Even if I did distill this and lost some of it, I would still do, you know, a lot better than I did in the first one. That's a terrible yield, 5% overall. But even if I distilled this and dropped it down to 50% overall instead of a 66, I'd still consider that pretty good. you know, for a beginner especially. Keep in mind, if you when you try to scale this up, that's how people blow up doing this reaction, because it's so exothermic, and you think you can double the amount of ice that you need because you doubled the reactants. It doesn't work that way. You might double the reactants, but you need 10 times as much ice. You know, and then if you double that, you might need 100 times as much ice. And then if you double that, even though you're only doubling the reactions, you can see the ice is going up by tens. You know, you might need 1,000 bags of ice now. And that's what happens. People don't understand that. And the ether comes out all at once, vaporizes, bam, it goes through your house, hits a flame, boom. Anyways, so you all have a great day, and always remember, science is great.